All right, we're going to talk about section 4.7 today, inverse trig functions. We'll break this into probably two videos, part one and part two. I'm going to power through this very quickly because I'm low on time. So if you need to slow it down and watch it again, please make sure you do. All right, to start, have you do some warm-ups here. Sine of theta equals a half. Find all values of theta between 0 and 2 pi. So once around the circle, how many times is the y value a half is one way to interpret that. The other way to interpret it is what right triangle is this? And then, what angle has the sine of a half? And then what quadrant would that reference angle be in, right? So two ways of approaching the same question. Unit circle seems good. We should know that in our unit circle, the sine of a half is going to be pi over 6 because that makes this little right triangle, which we recognize as, hey, that's pi over 6. So the answer, sine is positive in quadrant 1 and in quadrant 2. So we're looking at a pi over 6 degree angle in both quadrants. So this is going to be theta equals pi over 6 and theta equals 5 pi over 6. Let's go ahead and do C next because it's related to that question. So the sine of theta equals negative 1/2 is the same question, except now sine is negative. And we know sine is negative in quadrants 3 and 4. And so now we're looking at our pi over 6 in quadrant 3 and our pi over 6 in quadrant 4, which means theta would equal, from standard position, wrapped all the way to 7 pi over 6, and then all the way almost around, stopping at 11 pi over 6. All right, cosine of theta equals root 2 over 2. What angle has that ratio of cosine? Root 2 over 2 should jump out at you as a pi over 4. And so now we got to think about where is cosine positive and negative. And we know cosine is positive with the x value being positive. And so we would be looking at this scenario. So cosine of theta equals root 2 over 2. I know that is a pi over 4 degree angle. So we're looking at these two angles right here. And so we're going to say theta equals pi over 4. Or we could say theta equals, wrapped all the way around to, what would that be, 7 pi over 4? Notice we could have said negative pi over 4. That's a perfectly good answer, except I asked for the answer between 0 and 2 pi. So we had to wrap around that way to answer the question. If I had taken that restriction off, then negative pi over 4 would have been a perfectly wonderful answer. And then the next ones are related. When is cosine negative? And we can see, of course, that that's related to when the x value is negative. So that puts us with a 45 degree angle in quadrants, what is that, 2 and 3. So theta equals, that'd be 3 pi over 4, or theta equals 5 pi over 4. All right, so what you just did in answering these questions is, in fact, did what we're going to do today. So you already know how to do this with one tiny nuance. So today we're talking about inverse trig functions. And what an inverse trig function does is exactly what inverses do. They switch the domain and the range. So here, our input for a trig function, right? Our input is an angle and our output is a ratio. And so today what we're going to do is we're going to write the function that reverses those, where I stick a ratio in and it spits out the answer, which is the angle. Okay, so first let's talk notation. There are three ways of writing inverse trig functions. The first of which is the one you'll see on your calculator. It says sine to the negative 1 power of x. Let's be very clear, that is not talking about the reciprocal of sine. This is not a code for cosecant. This is the function that will take a ratio in as an input and spit out an angle as an output. It is also referred to as the arcsine. Inverse sine and arcsine mean the same thing. And to shorten arcsine, we will sometimes write a sine, but we will never say a sine because we would sound silly. That is still called the arcsine, or you can call it the inverse sine. So then we have inverse cosine, we have inverse tangent, and yes, you can do inverse of the others 3 as well. Get familiar with that language because we'll mix it up and use it interchangeably. All right, so let's take a look at these couple of warm-ups. And I would like you to notice that the first one doesn't seem like it fits. And it doesn't. This is not a trig question. But I put this on here to remind you that what we're going to do today is, it should feel very familiar, which is when we first learned logarithms, we didn't know how to find a logarithm. And I guess one could argue we still don't, because what we know instead is how to solve an exponent. So instead of answering log base 2 of 16, we translated it in our head, excuse me, or wrote it down to be like this question, 2 to what power equals 16? And then we thought about it for a minute. We said, oh, I know the answer to this. That's 4. Excuse me. So we answered the logarithm question without really knowing what you do to answer a logarithm question. Or said a different way, this is how you answer a logarithm question. You write it as an exponent and you take a look. So let's look over here at part B. So this is saying, and there's, I guess, an implied equals what here. And the what in question would be an angle, because my input is now a ratio and my output is now an angle. Whereas the reverse for a regular sign, right? Regular, you would say sine of theta equals, some unknown. Call it X or Y, or doesn't even matter. And the input was a angle and the output was the ratio. So this does, and what inverses do, it swaps the input and the outputs. So how are we going to answer this question? Well, we're going to think about it and come up with the answer. And what are we going to think about? We're going to think about this question. Sine of theta equals what? Equals the ratio of a half. So then what is the answer to this question? And we just did this in warm-up part A. We know that theta equals pi over 4. Nope, that's a lie. Pi over 6. We also said it equaled 5 pi over 6. Now, those are 2 answers. They are an infinite number, but even having 2 answers suddenly becomes a problem, because I'd like to go back and highlight one word here, and that would be the word functions. These are supposed to be inverse trig functions, and we know that a function is only supposed to return one answer. So we're going to have to make a decision about what answer this returns, because it's not going to give us both of these. So the short version, and we'll get more formal with it later, the short version is it's always going to return the first value that it comes to. So when looking at analyzing, like angles rotating either this way or this way, what's the first angle you come to that would have a sine of theta of a half? And the answer is the pi over 6 comes before the 5 pi over 6. And certainly becomes before the negative, 7 pi over 6. So long story short, our answer would be this one. That is what, if you go to the calculator right now and ask this question, it'll give you this answer. It will not give you that answer. If you want additional answers, then you'll need to figure out, what do I do with this information? All right, we'll get back to that later. All right, so the next question, arc sine of root 3 over 2. Notice I changed the notation. But it means the same thing. So all I have to do is answer this question. Sine of what angle equals root 3 over 2? And root 3 over 2, we should recognize as a 60-degree angle for sine. And so this is going to be theta equals pi over 3. There are other answers that theoretically would work here, but we're going to give just the primary answer, which is the first one. Arc cosine, inverse cosine of root 2 over 2. We know this is pi over 4. And so what is the first answer? That pi over 4, in a triangle, in a circle. So we wrap around and we hit pi over 4. So there's your first one. I would like to point out that negative pi over 4 also works. So they're both the same distance from 0. I hope everybody's okay with the fact that, we mathematicians all got together and agreed that, hey, let's just return the positive one. So when in doubt, it's going to be the one that's positive if that answers the question. So, so theta equals pi over 4. That is what your calculator would tell you. And then the arctan of 1 is asking us in a unit circle or any representation here. The arctan is 1. So we've got a triangle, and we should know that's 1 and 1. Oh, that's going to be 1, 1 squared of 2. Hey, that's pi over 4 again. So this is going to be theta equals pi over 4. Okay, so those would be our answers. So it seems like the lesson should be done, and I guess in a way it kind of is. This is 90% of what the practical use is going to be here. But let's just kind of dig in a little bit deeper to make sure we have a full understanding without losing sight of this is all we're talking about. All right. So what I've asked you to do is to graph sine. So I'm going to speed this up a little bit because I am going to run out of time here. I guess I'll go as far as I can and then stop the video. All right. So I've asked you to graph sine. So we're going to label pi over 2, label 1. And I'm going to get a very quick but accurate graph of sine. And again, I'm using 2 blocks, but notice I'm only labeling, kind of paying attention to every... Oh, I missed one here. That was a mistake. That's going to slow me down. Go over 2. Go over 2. Ignore that one. Oh, man. And then we're over here. Okay. What was I saying about accurate? I guess it's accurate now. All right. So I asked you only really to go between negative 2 pi and 2 pi, and I did more than that. So negative 2 pi would be right here, and then 2 pi would be right here. So that's the part I'm more interested in. All right. So now what I want you to do is graph the inverse sine. So I'm asking you to do what we do, which to graph inverses, which is we just switch the x and the y. So what does that mean? Well, on regular sine, this is angle measures in radians, right? That's what we usually use. And then this is just the ratio, so this is just a number. And so when I find the inverse, that's going to flip the labels on my graph. So now we have, this is the ratio as my input, and now angles and radians is my output. All right, so we know that sine is the point 0, 0, so that flips to be 0, 0. Let me do some labels here. Let's call that 1. Let's call this negative 1. And then this would be pi over 2. This would be pi. 3 pi over 2. And 2 pi. This, of course, is negative pi over 2. And negative pi. So, again, 0, 0 becomes 0, 0. We go over to pi over 2, and we get a value of 1. And so we're going to reverse that and go to 1 and up to pi over 2. The point pi 0 is on sine, so we have 0 pi. We have the point 3 pi over 2 is negative 1, so we reverse that and get negative 1 and 3 pi over 2. And then back to 0 and 2 pi. Negative pi over 2 is negative 1, and negative pi is back to 0. So we're getting a graph that looks like this. And now we can clearly see it's not a function because it fails the vertical line test almost, well, in fact, everywhere. And so our job right now is to figure out, kind of like we did with a parabola, right? We said, hey, we've got this thing called a parabola. We love it. It's great. It's fun. And then let's find its inverse. Well, its inverse would be this. And we're like, oh, hold on, not a function. So what did we do to solve this problem? We limited how much we're going to rotate or inverse of the functions. So we limited it to, hey, let's just take this portion of the parabola. And so then when we find the inverse, we get an answer that is a function. And then we can use it and do what we do with functions, which is to get outputs. So we need to do the same thing with sine. So let's go back and look at our sine wave. So we got to do two things. We have to make sure that we create a one-to-one function. So for example, we wouldn't want to say, oh, let's flip that part. Because if we flip that part, then clearly we would still not have a function. We would have that part. Okay, so that's not going to work. So we could, I guess, instead just do from 0 to pi over 2, because that would be 1-to-1. And then that would give us this answer. The problem with that is we know that our inverse trig function has got to accept values that are ratios and give us angles. This would only do that for values that are positive. What about our inputs that are negative? Okay, we need to be able to return the answer when we ask the question, like if it's not clear what I'm talking about. If I ask you the question, what is the arc sine of -1/2? If all we do is look at this yellow highlighted portion, well, we never, -1/2's over here. We don't have an answer for that. So long story short, what we're going to end up doing is we're going to end up taking this portion right here. We're going to limit from -pi/2 to +pi/2. We're going to take 1/2 of the period, but a piece of the period that includes negatives and positives. So that when we flip it, we get this function right here. So only the yellow portion is what we would consider the graph of the inverse. So all the rest of this would go away. So we're looking at this graph here. Let me erase that. There's your graph of arc sine. Now, how does that translate to us finding the answers? Well, if we go back and look at our first warm-up question, I asked you the question, when is the arc sine, or when is sine of theta, when is it 1/2? And we said, go ahead and give the answers between 0 and 2 pi. And we ended up giving two answers. We gave pi/6 and 5pi/6. Well, which answer, if I ask the calculator, is it going to give me? It's going to look at this and say, okay, you asked me about +1/2, that's right here. And so it would come and look at this y value and say, oh, that's pi/6. And if I asked you what's the arc sine of -1/2, now I'm asking you, here's an input of -1/2, what's the y value? So the answer is going to be different than what we got up here. We answered the question, what angle has a sine that is -1/2? And we came up with 7pi/6 and 11pi/6. So if we come back and look at our graphs, we came up with the answer, hey, when is it -1/2? So we went around quadrant 1, then we went around quadrant 2, and then we got to quadrant 3, and he said, oh, there it is. And we said, oh, it's also here in quadrant 4. That's your 7pi/6 and your 11pi/6. But that's not the answer we're going to get when we ask the calculator this question. We're going to get the answer that is the one closest to 0, which is going to be the one that is in quadrant 4, but we're going to get there by going in the negative direction. So we should get an answer of -pi/6. And again, if you just think about what's the angle closest to 0, positive or negative, that gets you this answer, that's the one we're picking. And you'll notice if it's positive, we're going to get an answer in quadrant 1. And if it's negative, we're going to get an answer that's in quadrant 4. If you look at this on a unit circle, just to kind of hopefully bringing us all together when asking, sorry, it's very delayed, when asking about what is the angle when sine is, say, positive, we're going to get an answer here in quadrant 1. So we know that all these have positive signs, and so it's going to give us the angle here in quadrant 1. And if we ask it about a negative ratio, we're going to know that sine is negative down here in quadrant 4. And so we're going to get an answer somewhere over here, but we're going to get it by going the quickest way in the negatives. So positive sine and negatives. All right. Hopefully that makes sense. We got to keep moving. Cosine. If we do the same activity with cosine, we're going to get a similar but different result because of the way cosine is slightly different than sine. So we've got our usual labels. We know cosine starts at 1. There's to 2 pi. There's to negative 2 pi. We can see that going from negative pi over 2 to pi over 2 like we did before, which would be here to here, would not work because we've got ourselves an issue with it's not a one-to-one function. So that would fail the vertical line test when I flip it. But also, and maybe more importantly, it also doesn't account for any negatives, right? This doesn't answer the question about negative ratios. So that is not going to be the same as what we did for sine. But I think it looks pretty obvious, I hope, that this region right here accounts for all the positives, all the negatives, and doesn't fail the vertical line test. So if we just focus on that portion, I think we'll be in good shape. So if I graph inverse cosine, same angle measure. So this is pi over 2. Call this 1. We know that the point 0, right, back on cosine, 0, 1 becomes 1, 0. We have the point pi over 2, 0 becomes 0 pi over 2. We have negative pi over 2, 0, so that's right here. And then we can kind of just pop the rest of them on here. And we get a graph that's very sloppy. My apologies. That starts to look like this. So we hopefully agreed that we're going to focus on this section here between 0 and pi. And so if I just rotate that portion, then that would focus on this portion here. And if we think about it on a unit circle, what did we say before? We kind of talked about cosine is positive here, and cosine is positive here. That's why we can't do what we did with sine. This is only for the positives, but we have negative and we have negative. And so anytime you ask the question about an angle, it's going to return you an answer. If it's positive, it's going to give you the answer in quadrant 1. And if it's negative, it's going to give you the answer in quadrant 2. All right. Hopefully that makes sense. All right. So let's go here and take a look and talk about the nuance here. If sine of theta equals negative a half, list how many answers are there, number 1, and let's list several of them. And the answer, of course, is there are infinite number of angles that have this sign. They're all coterminal with 2 places, but they're all going to be, let's see, a version of pi over 6, but it's negative. So it's going to be pi over 6 in quadrant 3. So again, we're looking at pi over 6 here and pi over 6 there. So let's list some answers. That would be 7 pi over 6. It could be 11 pi over 6. We could frankly wrap around again. So we would go to, let's see, 19 pi over 6 and 23 pi over 6. We could do this all day. let's go negative. We could go negative pi over 6. We could go negative to here. That'd be negative 5 pi over 6. And we can wrap around again and again and again. There's an infinite number of answers. Okay. Now, part B, same basic question, right? This is me now saying what angle has a sine of negative a half. That's exactly what this question's asking. However, there is only one answer to this question. Okay. By default, the calculator, a computer, a function can only return one output. That's what functions do. And so which values are going to give us? It's going to give us the answer that is closer to 0, right? It's not going to give us this one because that's pi over 6. That's positive a half. It's going to give us this one. This one right here is negative 1/2 for a sine. And so the answer is going to be simply pi over negative pi over 6. This one right here. And if we do the same thing, sine of theta is root 2 over 2. That's going to be a 45-degree angle. It's going to be in quadrant 1, so that's pi over 4, or quadrant 2, so that's 3 pi over 4. We could wrap around again and get 9 pi over 4, etc. We could go in the negative direction, and we'd have to go all the way around to here. So that's going to be negative, let's see, 3, 4, 5 pi over 4. We could get negative 7 pi over 4. And then when I ask the same question as an arc sine, it's going to return only one answer. Which answer is it going to give me? It's going to give me the answer that's in quadrant number 1 because it's a positive ratio. So the answer is simply going to be pi over 4. Cosine of theta is negative a half. Cosine, lots of answers here. So where is cosine negative a half? It's going to be pi over 3 reference angle. So it's going to be pi over 3 here or pi over 3 here. And so the answer is going to be either 2 pi over 3 or 4 pi over 3. And we can keep going around and around. We can also go in the negative direction. So we could have also said negative 2 pi over 3. We could have said negative 4 pi over 3 and go around and around. If I ask this question as an arc cosine question, however, it's going to return one value, and it's going to give me the value. Now, again, notice they're both the same distance apart if I go positive or negative, but we want the one that's in quadrant 2. That's what we looked at our graph, and so the answer is simply going to be 2 pi over 3. And cosine of theta is 0. That's going to be when the x is 0. So that's going to be here and here. So pi over 2, 3 pi over 2, 5 pi over 2. We could go negative pi over 2 would put me here, negative 3 pi over 2, etc. Arc cosine of 0 is going to return one answer, and it's going to return an answer between 0 and 2 and pi. And so your answer is simply going to be pi over 2. All right. To hammer this home and kind of the final word on this piece of it, this is familiar. We've done this before. For example, if I ask you to tell me the answer to x squared equals 16, you're going to tell me x equals 4. You're going to tell me x equals negative 4. Those are both correct answers. Why are they both correct? Because when I plug them in, 4 squared is 16, negative 4 squared is 16. But if the next day you come in and you see this question written on the board, the answer is only 4. Because notice the difference, right? This is x equals the square root of 16. So someone has already done the square root. We are using this truly as a function, and the function gives us only the primary root of 4. Okay? We're not answering this other question of find all values. It's going to find you the primary value only. If you want all values, then you have to then understand that, ooh, this helps me, and then I could figure out that -4 also works from there. But this is what the calculator would return. It would not return both of these. Okay? So it's the same thing. We went from more than one answer, just as a logical thought process, to what does an official function tell us? It tells us only one answer. So hopefully that helps too. All right. We are going to go a little bit further and then shut this down. Okay. Arcsine of the sine of pi over 6. The sine of pi over 6, right? So if we go our order of operations and we go inside of here, the sine of pi over 6 is 1/2. And so then this question just says, what is the arcsine of a half? Which is asking us to basically undo what we just did, right? So now we say, oh, the arcsine of a half is pi over 6. So in a way, the arcsine and the sine cancel each other out. We're left with pi over 6. All right, seems fine. Let's do the one below it. So if arcsine and sine cancel each other out, then logic would tell us the answer is 5 pi over 6. And that's where logic is going to fail us. The answer is not 5 pi over 6. The answer is pi over 6. Why is it pi over 6? Because of the facts that we just talked about. So if we repeat the same thought process here, the sine of 5 pi over 6 is going to be 1/2. And so this question is now asking the arcsine of 1/2. The arcsine of 1/2 is not 5 pi over 6, right? Back to our picture. We just did this. We said, okay, 5 pi over 6. So first of all, we did pi over 6. And we said, okay, what's pi over 6? And we said it's 1/2. And so then when we did the inverse, we got back to pi over 6. The second question asked us about 5 pi over 6. So what's the sine of 5 pi over 6? Here's 5 pi over 6. We say, oh, it is 1/2. Yay, great. But then when we do the inverse of that, it's not going to return this because it's outside of the range. It's going to return the one that's inside of our range. And so the answer would be pi over 6. So while, yes, you can sort of think about arcsine and sine canceling each other out, we have to be very careful and think about how the math actually works. So the answer here would be simply pi over 6. What is the arcsine of the sine of 7 pi over 6? So we know that the sine of 7 pi over 6 is -1/2. We're over there in quadrant 3. So now when I ask you for the arcsine of -1/2, now I'm asking you to undo what we just did. However, 7 pi over 6 is out of our range. What angle is in range that also has a sine of -1/2? That would be -pi over 6. On a unit circle, let's see what we just did. We said, hey, come over to 7 pi over 6. Here it is. What's the y value? Oh, it's 1/2, -1/2. Then we said, cool, what angle close to 0 also has a sine of -1/2? And that would be this angle right here, -pi over 6. All right. Let's try a couple more. Arc cosine of the cosine of 2 pi over 3. Now, cosine and arc cosine are a little bit different looking, right? Because our answers are going to be in quadrants 1 and quadrants 2. So if I ask you for the arc cosine or the cosine of 2 pi over 3, we get this answer. And so then the arc cosine of that, even though it's in quadrant 2, we don't care because quadrant 2 is fine. Long story short, this is going to be 2 pi over 3. But again, why? let's just take a quick second. The cosine of 2 pi over 3 is going to be negative 1/2. The arc cosine of negative 1/2, you will recall, right? We are looking between 0 and pi. And so we're saying what angle has a cosine of negative 1/2? It's going to be this angle right here, which is going to be the 2 pi over 3. All right. I'm going to hope that you're understanding this. Cosine of 4 pi over 3, well, that's going to be down here. That's going to be negative 1/2 again. And we know that when we do the arc cosine of negative 1/2, it's going to give me the answer in quadrant 2. This answer is also 2 pi over 3. The arc cosine of the cosine of negative pi over 3 is going to equal, so negative pi over 3 puts me right here. Negative pi over 3, the cosine is positive. And what angle is going to have the same cosine? It's going to be this one. So our answer here is going to be positive pi over 3. That's what the calculator is going to give us. And then here, the arc cosine of the cosine of pi over 3, that's just going to cancel out, because when we find this answer of the cosine and then we do the arc cosine, it's going to return the answer in quadrant 1. This is in quadrant 1. We get pi over 3. Understand that this is not a typical activity you would do. This is more of a thought exercise. We're not going to often do arc cosines of angles just to return the angle. Like, that's not something we're typically going to do. Okay, so this is more of a thought exercise, making sure you're understanding how arcsine works. All right, I think it's probably best to stop the video here. The next thing we're going to talk about is what does tangent and arctangent look like, but we're going to save that for video 2.